this is a really important lesson. This is about converting between moles and mass. We've learned about Avogadro's number and how we count out particles, but I can't count out molecules of water. But I can use a balance and weigh things out in grams. And so that's what we're going to learn today. So here's my question. How heavy is a mole? The answer is it depends. It depends on what we're talking about. If I were to pile up a mole of carbon atoms, let's just say I've got 1 mole, which would be 6.02 times 10 to the 23rd atoms. That mass of carbon would weigh 12 grams on a balance. Okay? Now, if I were to count out that same number of atoms of lead, guess what it would weigh? A lot more, 207 grams. So the same number of atoms of 2 different substances have 2 different masses. Can you see where I'm getting these numbers? Okay, yeah. So let's talk about a new term called molar mass. And we're going to be using this, for the rest of chemistry. Molar mass is a really big deal. So the definition of molar mass is the mass in grams of 1 mole of a substance. It could be an element, it could be a compound. Okay, so the mass of 1 mole of lead is 207.2 grams. Okay, and so I would say the molar mass is 207 grams. And that is only true for lead. No other element has a molar mass of 207.2. So what you're going to use is those little atomic masses, which are right there on the bottom of the block in the periodic table. Those are the molar masses in grams per mole for all the elements. Now, what if we have a compound? Okay, because most things exist as compounds. Let's find the molar mass for a compound. Well, you know what a formula means, right? You've got 1 calcium. We're going to use the subscripts here. 1 calcium, 2 nitrogens, and 2 times 3, 6 oxygens. So all we're going to do is go ahead and add up all of these little parts. So I've got 1 calcium, and the molar mass, I've got these for you here, is 40 grams per mole. So 40.8 grams of this is calcium. And then the nitrogens, I have a 2 out here outside the coefficient of my nitrate. So 2 times 1 is 2 nitrogen times 1401 grams per mole. So that's 28.02 grams of nitrogen. And then the oxygens, there are 2 times 3 or 6 of them, and each one is 16 grams per mole. So the oxygen is going to contribute 96 grams. Okay? So there are the masses of each of the elements in this compound. We're going to add these up, and we get 164.10 grams per mole. This is the molar mass for our compound. So to find molar mass, all you need to do is add up the masses of all of the elements contributing to that compound. Okay, and use your subscripts. That'll tell you how many atoms. So that's molar mass. Now, you're going to do this hundreds of times in chemistry, so it'll get easier the more that you do it. Now, what is molar mass used for? We are going to use it to convert between moles and mass. Okay, it's just what you think it is. So let's do our conversion here. So we want to find the mass of 0.125 moles of calcium nitrate. Okay, because if you want a certain quantity, you can't really count these things out, but you can go to a balance and weigh it out. So let's convert it to grams. All right, so we're going to multiply by some factor. And I'm going to draw a line here, right? I want to get rid of moles, and I want to go to grams of calcium nitrate. Okay, now what is the relationship between grams and moles for calcium nitrate? Guess what this is right here? That is your good friend molar mass, which we just calculated. Okay, that ratio of grams per mole is molar mass. So there it is, 164.10 grams per mole. Okay, so when we multiply, what happens? Moles cancel, and we're going to end up with, let's see, 20.5 grams of calcium nitrate. All right, so if you go to the lab and you weigh out 20.5 grams of calcium nitrate, you know exactly how many particles you have. You have 0.125 moles. All right, can we use molar mass going the other way if we have grams going to moles? Well, here's an example. I still got my calcium nitrate, so let's start with the mass. We have 55 grams of calcium nitrate. And this time we want to go to moles. So let's set up our conversion factor. Units first. I have grams, so I'm going to put that on the bottom, grams of calcium nitrate. And then I want to go to moles. Okay, and when I'm all done, I'm going to end up with moles of calcium nitrate. Okay, now the numbers that go in here, what's the relationship between grams and moles? Well, it's molar mass, right? 1 mole of calcium nitrate is 164.10. Is that right? Yeah. Okay. So when we multiply, what happens to our units? Grams on the top, grams on the bottom. All right. In the calculator, 55 divided by 164.1. And that's going to give me 0.34, because I want to hang on to 2 sig figs. All right. So I have a fraction of a mole of calcium nitrate. All right, molar mass is really, really powerful, and it is going to be the key to going back and forth between grams and moles. So here's your conversion factor. Now, why did I not write in a number here with the grams? When we used Avogadro's number, I knew exactly how many atoms were in a mole. Why is there a question mark? The answer is it depends on the substance. Okay, so you've got to find the molar mass of a substance. So if it's a compound, you just add up the molar masses of all of the particles involved in that compound. All right, just takes a little practice. You can use molar mass to convert back and forth between grams and moles.